So like, start off when the world accepts me with a title executive in it, things have gone horribly wrong. So just to give you that heads up. I am, the best place to get a hold of me is Botchagaloop on Twitter. It's kind of my portal for everything. So they say if there's anything that's interesting in this session that you like, reach me there. If there's anything you think really sucks, reach me there. So that's the skinny on that. So I'm going to do, basically this is what I'm going to talk about. I'm going to talk about kind of a little bit of intro about myself, so you know why. This is my actually 4th year speaking at PuppetConf. So every PuppetConf, I somehow trick them to let me come back. So, but I actually did the first one in Portland. So it was awesome to hear that they're doing it again in Portland, because by the way, the best one was in Portland. I'm going to do an SDN overview. I'm going to talk about kind of DevOps, SDN, all sorts of stuff. But a lot of this discussion, before I get into myself, is really about the opportunities. I do a lot of keynotes. I'm like one of the core founders of Devops Days in the US. I was at the original Ghent 5 years ago. We're having a 5-year celebration next month. So in some of my later keynotes, I've been talking about trying to get the DevOps community kind of excited about a broader view than just compute. We tend to be myopic about compute. It's good, like it's gotten us here for 10 years, but it's enough. Enough is enough. Let's start thinking about network and storage and those things as well. So who am I? This is my 4th decade. I'm about to start my 10th startup. I'm 55 years old, right? So anybody tells you can't get a job after 40 is full of shit. I started out as a mainframe dude. I was actually a Tivoli guy. Most of you probably don't even know what that means. I was actually a cloud dude, and this is kind of interesting. I was the 9th person in at OpsCode Chef, and this is my 4th Puppet conference. So yeah, I built the whole customer-facing business for OpsCode. I was the first technical non-software engineer. So I'm an engineer, but I built the whole customer, everything, a lot of the team that still exists there. And then, so I did that, cloud and chef and infrastructure, and in fact, the only reason I didn't work at Puppet Labs is I begged Luke 8 years ago for about 2 years to give me a job, and he wouldn't do it. So then I begged Adam Jacob for a job, and he did do it. So and now I'm like a network dude, question mark, right? So I'm not really a network dude, but I spent the last year. So I had an exit with a company called Stratus, was sold to Dell, and I was looking for my next big thing, and I just started playing around with networking and DevOps. And so a lot of this is what I've learned over the last year. So Adam Schaefer, or Andrew Schaefer, why do I call him Adam all the time? Andrew Schaefer, he was one of the original founders of Puppet Labs. He did this great with a blind man and the elephant on DevOps when it first came out. So I completely stole that from him and used it for SDN. So here's the thing, right? I'm going to go into what I think is a clearer definition of SDN in a little bit. But it's okay that people use it as a sword for a lot of activity. Just like people say cloud, right? Like I don't get really upset. Sometimes I get upset. I don't get too upset if the majority of discussion is around really cool stuff and they decide to call it cloud. I mean, as long as it's reasonably related. And I think a lot of that's going on with SDN right now. So there's some purist definitions of SDN, and then there's some kind of, yeah, I think that's okay to put it under the umbrella of SDN. And so these are some buzzwords that hopefully if you don't know what they are, I'll give you a little bit of a clue on what they are by the end of it. But the blind man and the elephant is everybody thinks their part of the elephant is something different. So what are some of the things that pop up a lot? Probably the most famous piece when we talk about SDN is something called NSX from VMware. How many people have heard of NSX? Yeah, okay, a small percentage. So that was basically VMware, a little over 2 years ago, bought this startup that had no revenue for customers for $1.2 billion. Let me say that again, $1.2 billion. I mean, but there was a reason for this, and I think and if you see what VMware is doing with this, it's pretty important. But that was pretty much as pure as you can get as an SDN product. And in fact, the founder of that startup was a gentleman called Martin Casado, who actually was doing his PhD in Stanford on a protocol that basically was and is attributed as the definition for SDN. So most people would say Martin Casado, the founder of Nicira, now part of VMware, the product line NSX, is the founder of SDN. So like anything else, there's a lot of people who were playing with this idea, but he gets a lot of the credit. NFV, Network Function Virtualization, I'm not going to spend too much time on that. Quite honestly, I think it's boring, but a lot of people think it's really exciting. I'll talk about OpenFlow a little bit, and then a project called Open Daylight, OVSDB. There's some other, VMware is not the only one with kind of a pure SDN product. There's a company called Nuage that's doing very well, has an interesting alternative to the VMware product. For those of you familiar with Juniper, they acquired an open source project called Contrail, which for many Juniper customers are pretty happy with. But here's the thing, right? So we talk about infrastructure as code, right? And again, you know, the truth be told, when we talk about infrastructure as control at ChefConf or PuppetConf or Devops Days or even Velocity, really 90% of our conversation is about compute primitives, right? And so what I want to do is make sure that if you're somebody who writes Puppet code and manifest or classes, whatever you do with Puppet these days, I want you to start thinking about what are the opportunities. And by the way, Puppet has been leading the charge. In fact, one of the first ones to actually start doing some Ruby gems on Juniper stuff and some really cool stuff, right? So the game is afoot with this community. And I just want to open up some of the more of the opportunities that I think that everybody that kind of rolls up their sleeves and calls them kind of DevOps-y, I think we should be doing. I don't want this to stick. Network is code, right? So infrastructure as code includes everything, or start telling people about network as code. And so what does that mean? Software-defined networking, network function virtualization, OpenFlow, Open-vSwitch. We'll deep dive into that. The two bottom ones are really interesting. This concept of network overlays. This is where you get into true virtualized networks. Probably the most prominent overlay right now, or you sometimes hear them called tunnels, is something called VXLAN. So VXLAN is used quite a bit by NSX and Nicira. And then another one that's really probably more interesting, getting closer to compute, is the Linux-based network OSs. So you have, like, say, Arista is an interesting example where it really is. They kind of broke them all. They were ex-Cisco people that went ahead and created really more a focus on an operating system than hardware. And, oh, by the way, there's some kind of operating system there. Like, their primary focus was more about the operating system itself. And in say, like an Arista device, it's actually a Fedora. I mean, so you actually go in there, you can bash into it. You can actually find, like, all the commands. There's Python scripts for every one of them. There's a true API. And there's some other vendors that have even taken that one step further, and I'll talk about that. So why SDN? There's a presentation. I don't know how well of a job I'm going to do in teaching you in 32 minutes now on what SDN is. If you kind of get it and you want to really get it, the place that I think is the best place to spot is there's a gentleman called Scott Shanker. He was a professor at Berkeley. He went to Stanford to teach them, which is actually the birthplace of SDN. He did all faculty presentation. It's out on YouTube. Again, Botchagaloop on Twitter. I'll say it right. He does a fantastic job of describing why SDN was created. And so I'll try to summarize it, that networks are hard to manage. The OpEx on networks are very complicated. If we thought the OpEx 10 years ago on compute was hard, it's nothing compared to networks. And in fact, 10 years ago, you could go to any large kind of legacy implementation and ask them what their compute to sysadmin ratio would be, and they would probably say 1 sysadmin to 50 servers. And if you ask them about switches, you'd probably get the same answer. Nowadays, if you went to, I've got this from secondhand knowledge, but if you went to JP Morgan Chase and asked them what their, again, secondhand knowledge, but I know a couple of companies like this now that are legacy, not web scale, not Google, not Facebook, but banks and insurance companies. They'll tell you that their ratios on sysadmin to compute nodes is somewhere in the neighborhood of 1 to 10,000, right? But you ask that same organization what their network operator or network engineer or whatever they call it, is still 1 to 50. So that just screams that we're doing, like, we're being myopic, right? And again, the networks are hard. I mean, they're hard to manage, and they don't have to be. And this Scott Shanker talks about a lot of this, And then they're also hard to evolve, right? A lot of the things that we do in networking are 30 or 40 years old. Router protocols, I usually joke that unless you were born in 1940 and understood, and hung out with Grace Hopper, you probably going to have a hard time rewriting router protocols, right? So they don't evolve very well. And again, Scott Schenker makes a real good argument. And then they're just hard to understand. And in code word, they're ridiculously hard in most cases to abstract. So the things that we do with abstractions, like file systems and users and services and all that stuff that are really cool that we do with Puppet and other products like Puppet, like the network has made it really horrible for us to be able to do those kind of things. And so SDN is kind of an approach to solve all that. And my good friend Network Static, he's got some great articles. This is Brent Salisbury. He basically, a year and a half ago, he was running OpenFlow in production. He got an NSA grant before anybody else was doing anything with it. He was actually running in production, and he's got a whole blog over the last 4 years of great articles about OpenFlow, SDN, and all that stuff. And this is one of his, he says, we're still kind of doing this tromboning thing from how we manage networks today, 15 years later. So managing the network is quite simple conceptually. So again, still driving on the YSDN. But what do we do with and I'm going to use switch. I'm going to call it switch. It's switch or router interchangeable. But basically, you got three major things. You got kind of routing. So you got distributed routed protocols. You have isolation, ACLs, VLANs, and then you have kind of traffic engineering. Right? Those are the three things that. So if I'm going to make the world better, networks are hard to evolve. They're hard to manage. They're hard to abstract. What are the three things I probably have to focus in on? Well, these three things. And so, all right, what is SDN? So how many people know what SDN is? So I got three hands. Out of those three hands, if I asked you to come up here and explain to the rest of the people, would you leave your hand up? Careful what you do. Oh, hey, that usually doesn't happen. Okay. I would never do something like that. But most people put their hands down when they do that. Although you guys are so far in the back, you think I wouldn't do it. People in the front would never do that. All right, so sorry. I digress. So here's the deal, right? So back in the day, basically a network device, a switch or a router interchangeable, basically would have three planes on it. A management plane, control plane, and a data plane. Data plane is packet in, packet out, wire speed. Right? It's a special chip to process that data plane at wire speed. Right? And then you had something called a control plane, which was kind of the distributed brains of all the data planes. And so what you did is you went into different router configurations and you did these magical commands that basically use very brilliant distributed computing science stuff. If you ever go back and start reading how these people invented things like BGP and OSPF, it's like mind-boggling how smart they were. And back way before people were doing things like REAC. But the problem is, as smart and brilliant as it is, not malleable for human beings, right? The ability to get it to really do what you want to do is not as, not as easy. And in some cases, oh yeah, you want that? Rewrite your own, call it BGPX, right? Write your own protocol, right? So what Martin Casado did as a study, looked at this problem at Stanford, and basically decided he was going to I wish I would have thought of that, move the control plane off of the actual box, this kind of brains of the operation, and make it more of an, I'll just use the word again, malleable type solution. So it's not these ingenious router protocols. It really quite simply is kind of a match table at the lowest level. So it's like, hey, instead of having these router protocols figure out. So again, if we think about the data plane, what we're really trying to do is some packet comes in a port, and based on some definitions of all sorts of things, I want it to go out that port or not go out that port, right? And again, the way to do that was very difficult. And he said, well, I can make this a lot easier by using a protocol that's called OpenFlow. And it's just one of many protocols. It just happens to be one of the more popular ones, where this protocol is this idea that I create a new definition in the control plane. I simplify it by building just matching, all sorts of matching things that I can see in the packet. And that determines what I do and where it goes, what port it goes, should it not go anywhere. Now, the thing is, it's not that simple, as this thing implies. But that's fine, because there's really smart people building what they call overlay solutions, like NSX, like Open Daylight, like Nuage, that are basically allowing, Gene, people saw Gene, he talks about unicorns and horses. He allows the horses to basically write policy that gets translated into that stuff. So I can write some policy that says, well, if it's coming from the database server from there, it should never go there, it can only go there. But the thing is that they write a lot of code that actually goes into this. And if actually you really want to see some interesting discussions about the edge cases and how difficult this is, there's a project called Frenetic from a woman from Princeton, where she does some videos where she talks about all these weird timing and race conditions. So it's not as trivial as this slide makes it look like. But in general, we're trying to make the abstraction of controlling the data plane more malleable for human beings by allowing us to apply policy on top of that. So what does that mean then? So if I build this separated control plane, and I allow humans to create policy that's a lot easier than having to be a computer science that understands distributed computing and incredibly hard math, now I can do really cool things. Now I can truly create virtual networks. Like, so if you think about VLANs, right? Like, VLANs are cool, but like they're very coupled to the device, right? I got to set this VLAN A, and VLAN A has got to be defined here, 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 and if I need to add somebody else, it's got to be defined here, right? So it's what I call a first-order abstraction. You're virtualizing a device. Now, true network virtualization, or these tunnels, or people would call them things like VXLAN and stuff like that, are completely decoupled from the hardware, because now the logic in the data plane can tell where that needs to go. So now I can start building these logical networks that have nothing to do with the physical topology. Is that making sense? Shake your head no if it doesn't. All right, yes, good. And so that's the first order solution here, is we get to create true virtual networks. And so what does that mean? Like, I can have a service or a network that says this is the virtual network, and guess what? It can move around. And if there's some instance that's part of that network that starts off here and needs to go there, that's okay. Because I don't have to go get, oh my goodness, we got to get people to reconfigure the devices and all that good stuff. So things like overlays, tunnels, typically VXLAN is one of the more popular. If you've done OpenStack stuff, GRE is used quite a bit. And so these are virtual networks. But it doesn't stop there. Because now, again, once you can apply logic in that data flow, literally you can do anything. And so what you're seeing a lot of people doing right now with NSX, the killer use case for NSX right now is what I call replacing firewall sprawl. Because you can start taking all those IP tables that are all over the place, and the firewalls that, like, I've walked into shops where they show me the change control for a firewall change, and like, you actually have to be smarter than the people who write router protocols to figure out how that's going to affect everything. That's a good one. But now you can take that policy and start simplifying at the data plane. And again, it doesn't stop there. You could put quality of service, load balancing. Imagine that. Like, I don't need to, nothing in HA proxy, I love it, but like, imagine if I could offload a lot of that stuff in the decision-making processing as a load balancer that, so now let me put this in context. Typically, this becomes a killer app on a hypervisor. So you got a hypervisor with a whole bunch of VMs on it. Now you got a data plane where I can manage all the traffic coming in and out, and now I can do, IP tables replacement, I can do load balancing stuff, I can do traffic redirection. I can also, like, really do killer monitoring stuff. They talk about, people talk about elephant flows and mice flows, right? Like, there are certain things that just go on forever with big packets, like a vMotion. vMotion will kill you, right? And you might even know what's going on. I mean, if you listen to some of the videotapes of the real bleeding edges at Nicira, they'll tell you that they're actually doing some traffic redirection on that. But in the meantime, imagine you could just send monitoring alerts to just let somebody know that there's actually your bandwidth on your physical hardware is getting hammered because somebody's doing a vMotion. An important player in this discussion is Openyswitch. So, there's two kind of models here, right? There's the VMware ESX vSwitch, which is the proprietary, and that's awesome, right? And if you're an ESX customer, and if you saw some of the really cool announcements of VMware, that's all right. They got an OpenStack reference implementation of ESX. I think that's really cool. I happen to like the other side of the fence, which is the open source versions. And so the open source version of virtual switch is called something called Openyswitch, sometimes just called OVS. And it has some really, in fact, the ironic part is the people who now control all the vSwitch stuff at VMware are the people who actually wrote all this stuff. So, and they actually do, like, they're pretty good citizens in contributing, so they do good job. So Openyswitch is a first-class citizen, used heavily in OpenStack implementations, used by a lot. So even the NSX has a multi-hypervisor version that uses OVS. Nuage is actually moving, the people I talked about earlier. Open Daylight, which is an open source SDN project that actually uses vSwitch. So Openyswitch is an important thing. And here's the thing, right? Like from a DevOps perspective or a Puppet perspective, I mean, go watch some presentations on the OpEx and the manual management of dealing with Openyswitch and something called OVSDB, which is this kind of database. I mean, you watch people on a video, watch the commands and going, oh, I could puppetize the hell out of that. Trust me. Like you'll be like, oh, I can't believe they're doing that. I could make that cool. Again, if I do anything well today, I get you inspired to go watch some of those videos. Okay? And go kind of deeper dive in here and find out, is there anybody in your OpenStack project even thinking about the OpEx cost? I mean, to me, I went out to a large bank about 6 months ago, and they're talking about moving, I think, 50,000 physical servers down to 5,000 servers, 1.5 million VMs in 4 distributed cages. And I started asking questions like, how many open vSwitches are you going to have? How are you going to manage those things? And what I was able to prove to them is that all the money they think they're going to save on consolidation, it's going to be 10x worse if they don't automate the hell out of the management and the discovery and the troubleshooting. And this is why I always run out of time. There's Phil Hopkins. Again, if you're not writing this down, that's okay, because you can say, why would I write it down? Or if you're like not writing down because you don't got a pen, get me on Twitter, because this is a good one. Phil Hopkins at the OpenStack Summit basically does a neutron troubleshooting thing where I'll give you the answer now. The VM doesn't get an IP address, but he starts backwards from the actual hypervisor, looking at the flow tables on Openyswitch, working his back to the neutron server. And if you don't know OpenStack, this is probably not making any sense. But the point is, if you watch what he goes through, you know, setting TCP dumps at certain layers, and there's namespaces which you have, and you're thinking, oh my God, anybody who has to manage an environment that does that, if they don't, you know, again, I'll say puppet up, you know, it's going to be really hard. So the overlays, the beauty of the overlays is they give us this virtual networking capability. I can start thinking about, you know, instance A, I don't care what physical switch fabric it's connected to. I want that to be part of a network with server C and D. And the reason you can do that is because those packets being looked at on the hypervisor can make the determination of where it goes regardless of the physical. And so, again, VXLAN is really one of the more popular. GRE has been used in a lot of earlier non-pure SDN implementations of OpenStack. SDT has not used that. It was actually the original Nicira product before VMware bought them. They used this SDT protocol. So that's SDN, right? And so now it's a little bit more about like umbrella SDN as a term. Right? So that's my kind of 5-minute version of what SDN is, why it's important, what can happen, what are the OpEx opportunities. I think the equally interesting thing is what I would say just software-defined everything, which is, again, my original plea is like, let's just stop talking about compute and let's think about the other things. So a few years ago, the buzz was something called converged infrastructure. And when people say converged infrastructure, they go network, storage, and compute, right? But they gave it to you in a box, which is okay, right? Unless that box didn't do what you wanted to do, right? Then it wasn't okay. So now VMware talks about software-defined data center. And so, and now what they're saying is, and again, depends on the vendor who's pushing it, what we really have today is the ability to kind of disaggregate everything. And so let me step back into so you got computers. So the disaggregation of computers, pretty easy what happened there, right? We originally had bare metal machines. We still have bare metal machines. Then we built hypervisors. So we carved up a bare metal machine into multiple machines. And then we came out with cloud frameworks, which was, I call, a second order abstraction. So the request for the resource to the resource is now totally decoupled from the hardware. That's why people love cloud, right? IP storage, I think the story there is things like object storage, Ceph, things like that. Again, a completely decoupled early storage virtualization. You take a box, you make it look multi-tenant, you carve it up. A second order abstraction would have been something where, again, my request for an object somewhere out there, completely decoupled administratively from what I have to do. Same thing now with pretty much the switches, right? So I talked about Arista earlier. Arista basically sent you a box. They sent you the hardware, but they gave you the operating system was Debian. Not Debian, I'm sorry, it was Fedora. And it basically was really malleable. You could SSH, you could run a bash shell, you can see the scripts, all that kind of stuff. More recently, I think, this is the slide I wanted to get to. So you got Arista, who I think put a really cool stake in the ground and really emphasis on the operating system, said, why not make the operating system just the standard Linux? Why not make all those really complicated commands just Python commands? Let's actually put an API on here so anybody can program to it. Juniper kind of followed a little bit. A good friend of mine, Jeremy Schulman, used to be at Juniper. He's now got a project we started, but he wrote the original Puppet Netdev stuff. So he wrote a Netdev gem on a Juniper. Cisco has gotten into the game. So those first three vendors still send you hardware, and with the software, the Insimni project, which is now kind of ACI, APIC, and all that stuff. So Cisco's getting the game. But then you get Cumulus, and Cumulus is here. Cumulus is really interesting because that's another whole step. What Cumulus does is they just sell you the network operating system. And they tell you, go buy your own hardware. Well, and so I'm an old guy, right? Back in the day, when you got Unix, you got an IBM with AIX, you got an HP with HPUX, or you got a Sun with Solaris. And then one day I woke up and they said, okay, here's your Linux, go find your own hardware. Well, that's kind of what Cumulus is doing right now, and I think it's really, really exciting for our industry, crazy exciting for people who do things like what you do in this room, right? Because now it really is like a server. I mean, it still has a hardware in it, especially like the servers that they ask you to do are certified, and there's 5 or 6, and actually Dell is one of them. So, and there's other ones. Sometimes they refer to these as what they call bare metal switching. And then last but not least, but still very nascent, is something called the Open Compute Project. It is a project there called Open Rack, I think it's called. And it's where Facebook, it's kind of where Facebook, so let me tell you a little bit of story of, 12 minutes, I'm okay. Cumulus Networks is a guy named, actually, let me step back one further. On October 14th, I'm running the first Devops Networking conference. It's Devops for Networks. It's actually in the Computer Museum in Mountain View, October 14th. It's free. It's modeled after normal DevOps Day. It's going to be a lot of fun. I got J.R. Rivers, who's the founder of Community as my keynote speaker. Got a great lineup. We're going to basically hack. We're going to have some presentation morning and a hack on like what we can be doing. So if you're in the area and you want to bring your Puppet stuff, let's do it, right? So see how we can do really cool stuff. Again, it's free. But J.R. Rivers basically was one of the architects of Cisco UCS. Went over to Google, and when he got to Google, he realized, he had kind of this epiphany at Google, that basically they weren't really buying Cisco, and every one time I say to some guy in Cisco, like, they've got a Cisco switch there. I'm like, yeah, okay. But the point is, in general, they were buying hardware in Asia and doing their own network operating system with a lot of open source stuff that just like worked. And then he realized that, my goodness, that's a great startup. And Cumulus is an amazing startup. They're funded by Andreessen Horowitz. I mean, it's a big deal, right? But that's where he got the idea, was that the big guys. So going back to Facebook, Google until recently usually doesn't tell us all the cool stuff they do. Facebook from day one pretty much tells everybody everything they're doing. That's what I love about. I don't care for Facebook the application, but as an IT junkie, I freaking love those people. But the Open Compute Project is all about how they build their infrastructure And more specifically, they're really starting to put out like how they do racks and top of racks and how they do it. And, and there's even some talk that like what they use internally is going to be open sourced, right? So that I think the Open Compute project becomes really interesting from switch, top of rack switches and aggregate switches and all that good stuff. So kind of moving a little further, I talked about these kind of, we need to start thinking in DevOps about not just compute. Let's think about how we store. So I think this is the thing. I did this at DevOps Days recently where I said, I would like everybody. So here, I know I ramble. If we don't do this, other people are. And we are the best people for building these kind of abstractions in other silos. In other words, I don't want silos of compute and storage. Like the people in this room, the people at ChefConf, the people at Devops Days, the people at Velocity have done an incredibly good job in the last 10 years building really good abstractions for compute. And as Luke said this morning, really moving the industry in amazing speed. And so if we don't, as a community, step back and say, wait a minute, are we being myopic about compute? Should we actually be treating network, compute, and storage as equal partners as perimeters? And when we try to build and define stuff, right? And again, if we do that, we win because we know how to do it better. I know I've got the whole religion thing going right now, but we win if we do that. We lose if we let some other people in some other silo define storage and some other people decide. So I think, what I think is you have to do is start what I call rethink declarative. What does declarative mean? Is it just a bunch of compute primitives or is it? So there's a great presentation by a gentleman called Derek Collison. He was originally the architect of Tibco. Then he created Cloud Foundry, good resume. Then he created something called Apsera that just got, I think, almost completely acquired by Ericsson. But he's got a presentation he did about 4 or 5 months ago. We talked about a world where you build a set of metadata. Let's call it a JSON file, right? And it says, this is my vCPU, this is my vMemory, this is my network perimeter, this is my storage objects. And I put that in and I hand it off to Puppet or whatever, and it kind of figures out how to parse that declarative definition to give my service everything I need. Right? And he talks about that, and clearly, if you read between the lines, he's implying that Apsera does it, but Apsera is kind of proprietary, and it's, so again, I do think you have to rethink source of truth. If you throw the network in, like the network is the source of truth. What the network is staying right now is the way it is, right? And I think you have to rebuild from there. He talks about kind of layer 7 semantics, like how do we, how do you make that kind of, going off the rails here, but if you ever seen Mark Burgess talk in some of his stuff, and he's got a great book, In Search of Certainty, he talks a lot about semantics and the difference between human semantics and complex adaptive systems. Right? And I know I'm going crazy here, but there's a whole discussion about how do we do a better job of getting human thought into declarative. We're like so far from really doing that really well, even with cool products like Puppet. So in summary, a lot of software-based opportunity if you buy into this software-defined data center, software-defined network, software-defined whatever, software-defined everything. Networks are certainly becoming more open. I mean, they've always kind of been open, but now open and usable and abstractable. Right? Because even whether it's NSX or I happen to like Open Daylight because it's all open source. So it's an NSX version that is all open source. But in either case, they all have rich APIs. So again, you can write primitives on top of Nicira very well. Network virtualization is totally disrupting the way we think and we do things, and more and more you're going to be faced with situations to start thinking about how does that logical network affect what you're doing and that service you're trying to define. Of course, private clouds are driving a lot of this, and dare I say, I almost made it out of 35 minutes. What's the word that nobody wants to hear me say? Come on, you got to get it. It's one word. Docker, of course. Come on. There are drinking games now invented on Docker, right? How many sessions can you go without hearing the word Docker 40 times? I think Docker's awesome. But again, like all this applies there too, not just virtualization private cloud, right? People are going to start building complex infrastructures around, around containers. And we might see mixed environments with hypervisors and container nodes. You know, a Docker node that has lots of virtualized containers on that node. All these things are going to still be as complex. Do we run Openyswitch on there? What kind of switching fabric do we have? How are these Docker containers going to communicate with each other? Are we going to use Linux bridging and make that same mistake we made 10 years ago with virtualization? Or are we going to jump right to the head of the class and build VXLAN and tunnels and good stuff like that so I can say this Docker instance can talk to that Docker instance and you don't have to configure anything other than create a policy on some controller plane. So what are the opportunities? Abstraction, 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 right? Like, you know, source control. So a year ago when I first started this, I was looking at the space, and the first thing I saw was, oh, everybody has network configs. Hey, well then why aren't you putting your network configs in GitHub? And by the way, once you get them in GitHub, there's this thing called Ruby templating. And in Python, there's something called Ginger. I don't care. Take your pick. Instead of cutting and pasting in those 40 IPs in the first VLAN, like have a little bit of just Ruby code in there that basically reads a JSON file that populates it. And guess what? You probably, unless you made your code wrong, which you should be able to get with some type of lint, then there won't be any missed comma. Right? So it was interesting to watch these companies kind of evolve. They're like, oh, yeah, that's a great idea. Why don't we keep network configs in a source control? Why don't we force network people to actually learn Git? And you want to, like that, they hate it. But then when the first time they do a review on a pull request, they kind of get it. So I walk in the room, I'm like, you know, I'm going to teach you something, and you're really going to hate it. And you're not going to like it, and you're going to be, why are you putting this pain on me? And it's not that painful, but then when you get them through this process of taking, hey, how about that network config that you worked with yesterday? Let's put it in here, and let's show you how you do it, and you're going to pull requests. And by the way, when you have pull requests, that's a peering opportunity. Wow, that's not a bad idea. And then, by the way, let me show you how you can do Ruby templating. Oh, wow, I like that. And then, like, if you really get lucky, you might actually set a CI loop up. And I'm not kidding. There are people doing this. And then things like Arista. Arista has virtual VEOS, they call it. So you can build kind of least spline topology of virtual instances and push it all the way through a Jenkins. I've done this. I've done workshops where you put the network config, you make a change, you put a request in, it goes through a configuration, runs Ruby templating, hits the output of a VEOS, and then and I'm trying to get my good buddy James Wickett over, who runs Gauntlet, to add primitives for cucumber testing on the back end of the behavior for what it can do. And then the classic network guy like, that will never test a production network. I'm like, get out of my room. No, but no, the point is I'll be pretty far along. So the concept, this all can apply. Unit testing, behavior, integration testing. Like, go down the hall and see if your network people are even interested in this conversation. So what are the low-hanging fruit stuff, as we got 2 minutes left? There's been some great stuff in Puppet for VLAN stuff. I think this is easy kill, but it's out there. You know, there's some good stuff for VLAN to port mapping, link aggregation. There's a Netdev, Puppet Netdev out there if you haven't seen it already. You know, so now you start getting into more of the things like Cumulus and stuff like that. Then you can actually start doing Puppet configuration for router protocols. Now, you're going to have to start doing that on kind of bare metal switches, things like Cumulus and stuff like that, less on say, Arista switch or something like that. But you can do this. It's just the stuff out there you got right now. It's not going to work on a Cisco. So, all right, we're almost done. I think I talked about this, automated tests. Immutable network devices, you can throw a switch out the 6th floor test. And then, you know, again, a lot of other cool stuff. Ending up 1 minute left, and there are some cool projects. They're geeky. They're not really going to help you a whole lot, but if you want to geek out, there's something called MiniNet, which is actually a container, not Docker, but container-based network. You can test stuff. And then I talked about the frenetic stuff. It's kind of interesting, the frenetic, if you want to just learn how the gory details of how you take that matching table and actually make it into things that happen. I always say CAMS, not AMS, you know, the flow, and that's it. I do a DevOps Cafe with my good friend Damon Edwards, and thank you very much.